Now that we've looked at a question about proportion and sample proportions and using them, let's look at one about sample means. Notice you're provided the data for 15 babies. It's the first thing you want to do is enter this into your list and run one var stats. And that's exactly what I did. Stat edit. I put it all into my list 4, and then I did stat calc one var stats. Now mine is in list 4, so I told it list 4, and I calculate. And I wrote down the sample mean is 30.8. The standard deviation of my sample, this is sample data, so I have to use S of X, is 5.1158. So I'm going to use that in just a moment. I'm going to use my calculator some more. So we are creating 95% confidence interval and state our conclusion. All right, so state, plan, do, conclude. State, we want to know if the scientists should be concerned that babies are taking longer to become potty trained. Here's our sample data. This is our summary of our sample. X bar is 30.8. Standard deviation of the sample is 5.1158. Okay. These are the ages in months that they were potty trained. On average, 30.8 months. So our plan, checks and assumptions. We have a random sample of 15 babies. To assume that 15 is less than 10% of all the babies in the population. Okay. So just the population of the United States, all babies in the United States. And then the third thing, this is not a large sample. So we cannot use central limit theorem. We do not know if the population is normal. So the only other option is that we check the distribution of the sample. So I can do that a couple ways. I'm going to go back to my calculator. I want you to look at some things on the calculator. If I go to stat plot and I create a histogram, I'm going to start with a histogram of my data that I put into list 4. Zoom 9 is zoom stat. I see that this is fairly it's definitely unimodal and fairly symmetric. That's what we're looking for. Unimodal, fairly symmetric. It's not skewed. It doesn't. There are outliers. Another thing we can look at, go back into plot. Also look at the box and whisker plots or a normality plot. I'm going to go to the box and whiskers with outliers. Zoom 9 again. Okay. Now here I am seeing that I have 2 outliers, but the outliers are balanced around each other. When you see something like this, these aren't that extreme. I'm actually choosing not to throw them out. I'm not going to consider them outliers because I have 1 on both ends. And we kind of talked about that in class. The plot does confirm the symmetry here. Because it's still symmetric and these aren't extreme outliers, I'm going to keep them in. So by looking at the distribution of the sample of 15 babies, it is roughly symmetric with no outliers. It is okay to use T procedures despite not knowing the population is normally distributed and sample small. Guys, if you wanted to throw out those outliers, you could. You could definitely throw them out. You would have to recalculate X bar and your standard deviations. Okay, so now, with conditions met, we construct a 95% confidence interval for a one sample mean T interval. One sample mean T interval. Why are we using T? Because we do not have sigma. We do not know population standard deviation, so we must use T. We cannot use Z as our critical value. To find T star, you can either use your table or you can do inverse T in your calculator. Inverse T, you have to do area to the left. So you can do just 0.025 and get the negative. You do area to the left and degrees of freedom, which in this case is 14 and minus 1. And that's how we get a T star of 2.145. So I take my statistic, 30.8. Plus or minus the critical value times the error of the, and that's how I get my interval of 27.967 and 33.633. All right, moving on. It does, if we should be concerned, babies are getting lazy. Well, it could be, if you look at the original problem, 26 months was the average that babies became potty trained. Well, 20 months is not in our interval. So yes, we should be concerned that babies are lazy because 26 falls our interval. B, it says explain what confidence, 95% confidence. This is similar to number 1. 95% confidence means in several random samples of 15 babies, 95% of the intervals produced, sorry for my misspelling, produced will have the true average potty training age. They will capture that true mean. And then on C, once again, you are asked to calculate sample size. Well, this was a t-distribution, but if I don't know sample size, I can't calculate degrees of freedom. If I can't calculate degrees of freedom, I can't calculate t-star. So my only option is to use z-star of 2.576. That's my 99% critical value on the normal. I can't use t-stars here, guys. I have to use z-star to solve for sample size. Again, we have to round up to 44 babies.